So triangle congruence, CPCTC, section 4.6 today. What's that stand for? It's a great question. That's the first part of the vocabulary today. Good question, Reed. Because CPCTC stands for, it's an abbreviation for corresponding parts of congruent triangles are congruent, which can be used as justification and proof after two triangles are proven congruent. Now, what does CPCTC mean? It means that if I have two triangles here, and if I label them CAT and DOG, cat and dog, get it? Spell word.
There's one cartoon.
Good.
Oh yeah.
Great stuff. Now here, so focus here. Let's say I have triangle cat and triangle dog, and I were to tell you that A were congruent to O, T is congruent to G, and AT is the same as OG. Now, based on that information, what triangle shortcut would this be? Which triangle shortcut is this? ASA, right? So pay attention here. So what CPCTC stands for now, that is, if I know these two triangles are congruent, so for example, like triangle CAT is congruent to triangle DOG, that the corresponding parts of those triangles are also congruent. So if the triangles are congruent, C and D are now congruent. Would you agree with that?
Yeah.
Okay. What about CA and DO? Would those be congruent? And CT and DG, would those be congruent? Yeah, that's what CPCTC stands for. Is if the triangles are congruent, all of the individual parts of the triangles are also going to be congruent now. Which makes sense. The triangles are congruent, the angles and sides have to match up to be congruent as well. Okay? So that's what CPCTC stands for. Now we're going to use that today to help us in some proofs. Now, alright, so proofs are just reasoning, which is what you've been doing for a while now. If I were to ask you like the question, why? Well, you give me a reason why. That's proving it. So corresponding parts of congruent triangles are congruent. Again, CPCTC is useful in proofs. If you prove that two triangles are congruent, then you can use CPCTC as a justification for proving corresponding parts congruent. For instance here, we always start with a given part. Whenever we're talking about proofs, we always start with a given part. Okay, so like they tell me AD is congruent to CD. So I write that here. And then I want to say my reason underneath it. My reason is given. That's given to me. I do not have to give a reason for it because it's given to me. I know that to be true because they say it's true. So I don't have to justify it. It's given. Same thing on the next one here. They give me AB is congruent to CB. What's my reasoning for that? That's given to me as well. Okay. They gave me these two parts. I have two given parts already. Do they give me any other information? No. So I can't say given for anything else. Okay. So I'm going to go to the next part. Now I'm going to look at the triangle. What else on this triangle do I know to be true? What do I know about that middle line right there? It's the same line, right? Yeah. So we would say BD is congruent to BD. And what's our reasoning for that, Claire? You said it earlier. How do we know BD is the same thing as BD? It's the same line.
What does it mean by reflex?
Reflexive property is the special name for that. It's the same line as also known as reflexive property. Like if you're like it's like the mirror image, it's reflexive. Okay? And I'll justify if you were to say same line, it's the same thing. But yeah, it's the same line. So now, how do I know my two triangles are congruent? Because that gives me side, side, side. So I have side, side, sides there. And always my last statement is always to prove. My last statement is always to prove. And what's the reasoning for my proof? CPCTC. So we're going to be doing some flowchart proofs to analyze this. That is all we're doing. So let's look at this first one here. It says complete each proof. It tells me PNQ, or angle PNQ, is congruent to angle LMN. What would be my reason for that? That is given. They give that to me. That's given. It tells me Pn is congruent to Ln. Who can tell me what my reasoning is for Pn being congruent to Ln?
Given.
That is given to me. So underneath my reasoning, I would say given. It says n is the midpoint of QM. And that's given to me. Now, let's use that information. If n is the midpoint of QM, what is something I know about that segment that's highlighted now?
QN is congruent to what?
QN is congruent to what?
MN.
How do I know that?
Because it forms a line.
Because that's just definition of a midpoint. It's a midpoint. Do we all agree that's what a midpoint means? It cuts it in half. The two sides are equal. That's my reasoning. Okay. So yeah, I know that these two sides are equal now. So are my two triangles congruent now?
Yes.
Yeah, so I'd say triangle PQN is congruent to triangle LMN. And what would my reasoning for that be? Side angle side. And the last thing, PQ is congruent to LM because of CPCTC. Corresponding parts of congruent triangles are congruent. And that's all it is right there. So we're just going to be filling in some of the blanks. All right?
Is it another one of those worksheets?
Yes.
Let's
look at number 2 when it comes up here.
Mine won't let me open it in Adobe.
That's weird. So let's look at number 2 here. It says triangle UXW and triangle UVW are right triangles. There's my statement. What's my reasoning for that? It is given to me. That certain part's given. Great. Next, it says UX is congruent to UV. Well, how do I know UX is congruent to UV?
It's given.
That's given to me. That part's already given to me. Great. Now I'm going to move on. It says UW is congruent to UW. How do you know it's congruent to itself?
Same line.
Same line or reflexive property. Nice job. Yeah. Great. So now I know. What do I know next about my triangles? Are my triangles congruent?
Because it's a 90-degree angle.
Because it's a 90-degree angle, so I'm going to say triangle XUW is congruent to triangle VUW. And what would my reasoning be? What triangle shortcut is this one?
Side equals side. Ow.
It's one of those special ones.
Oh, it's the 90-degree one, which is the...
It's hypotenuse leg, or HL. Why is it hypotenuse leg? Because I have a right angle, and I know the hypotenuse, and I know they share a side. So that's hypotenuse leg. Then my last part is always what I'm trying to prove. So I'm proving X is congruent to V, and what's my reason for that? CPCTC. Congruent parts of congruent triangles are congruent. Nice job. Taking that information,
Correct.
try this one on your own. There are 3 blanks for you to fill in, A, B, and C there. Fill in the missing parts on this one. All right, so let's look at this here. It tells me PQ is congruent to RQ, angle PQS is congruent to RQS, and what would my reasoning for that be? That's given to me, right? Good. So next part says reflexive property. Well, what else do I know here then, Anderson? QS is congruent to QS. Nice job. And what was the reasoning for that one was? It was reflexive property. So now I know that my 2 triangles are congruent. So how would I state the triangle congruency, Katie?
Angle PQR.
Triangle PQR? No, not triangle PQR. Triangle PQS
Yeah, sorry.
is congruent to what?
QSR. Triangle QSR.
RQS.
RQS. So there's triangle RQS. And then last but not least, PR, or P, angle P is congruent to angle R. And what would the reasoning for that be? CPCTC. Nice job. Good work. All right, next part here. We can also use the coordinate plane to prove triangles congruent. For example, if I have the coordinate plane here, I have triangles in the coordinate plane. I can use the distance formula if necessary, okay, or Pythagorean theorem, either way. I can use distance formula or Pythagorean theorem to show that the triangles are congruent. So here we go. I have the coordinate plane here. I'm going to use the distance formula. Instead of the distance formula, what else could I use? I could use Pythagorean theorem. Okay, so if I look here, I could make a right triangle and use Pythagorean theorem and find the distances as well. Either way, my goal is to find the distances of all these and to see if they are congruent. Okay, so again, it's just a lot of the distance formula.
Wait, so how would you?
So let's look at number 4 here. Okay, as I look at number 4, there is a side length that is very easy to calculate. Which one is it, Becca? RS. Why is RS a lot easier to calculate, Becca? Because well, they're all straight lines. Because it's a horizontal line. Does everybody see that? Horizontal and vertical lines are a lot easier because I can just count the boxes. So if I were to look, Becca, what is the length of RS? 7. Now, if I were to look, Becca, which one is RS probably similar to? So I'm going to say YX. And what's the length of YX then, Becca? That one's 7 as well. Great. So right there, I already found 2 side lengths. Awesome. Now I'm going to find another side length. Oh, let's find RQ. How can I find RQ here? Can I use distance formula? Could I also use Pythagorean theorem? Well, let's use Pythagorean theorem. I like Pythagorean theorem here. Let's use Pythagorean theorem. Well, I want to look at my side lengths. What are my side lengths here? The bottom is, the left side is, so I would say the square root of 2 squared plus 3 squared. What's 2 squared? 3 squared? 4 plus 9 is? Square root of 13. Square root of 13 here. Which one is RQ similar to? I would say WX. So again, I'm going to draw a right triangle. Okay. What are my side lengths there? 2 and 3. So I would say square root of 2 squared plus 3 squared. What's 2 squared? 3 squared? 4 plus 9 is? So I have square root of 13. Great. Now I'm going to do my last sides.
Wait, was that a 7 on the side?
What?
Is it 2 on RQ? Was that a 7? 3.
3.
Oh, it looked like a
3 squared.
These triangles are congruent.
And then I have QS here. So I'm going to look at QS. Gentlemen. If I look at QS here, I'm going to draw my right triangle in. QS has lengths here of 3 and what's the other one going to be? 5. So square root of 3 squared plus 5 squared. What's 3 squared? 9. 5 squared? 9 and 25 is square root of 34. Square root of 34 is just 34. Square root of 34. And then the last one, I have WI. So I find my length here, 3 and 5. Guess what that's going to be? Square root of 34. I have 7, 7, square root of 13, square root of 13, square root of 34, square root of 34. They are the exact same. So why are the 2 triangles congruent now? Nope. What triangle shortcut would show that the 2 triangles are congruent? What did I find? I found all the sides, right? So it'd be side, side, side right there. Because I'm finding all the side lengths, it's going to be side, side, side. Okay. Let's look at number 5. Let's look at number 5 here. I'm going to erase here. I'm going to start off with BC. If I look at BC here, my side lengths are 1 and 3. So 1 squared and 3 squared gets me the square root of. Great. What's BC going to be similar to? Okay, draw my right triangle in there. What are my side lengths there? 1 and 3. So 1 squared plus 3 squared gets me square root of 10. Great. Those two sides are done. Now let's do, I'm going to do CA. Okay, so CA is next. Make my right triangle. I think I have 2 and what? 2 and 7. So I have square root of 2 squared plus 7 squared. 2 squared is 7 squared is. That gives me the square root of 53. Then I'm going to do LJ. So I got LJ. Did they really? So I have LJ here. What's the side lengths of LJ? 2 and 7. So I have square root of 2 squared plus 7 squared. I get the square root of 53. Nice job. And now the last thing here, I have AB. What are my side lengths of AB? 3 and 4, aren't they? 3 and 4. So AB. 3 squared plus 4 squared. 3 squared is 9. 4 squared is 9 plus 16 is, what's square root of 25? 5. That comes out to be whole number 5. And then the last one here, KJ. Make my right triangle here. 3 and 4. What's KJ come out to be? 5. I have square root of 10, square root of 10, square root of 53, square root of 53, 5 and 5. Are they the same? Yep, that'd be side, side, side again. Nice job. Last but not least here, try these on your own. Same idea. Okay, take a couple seconds, plot the coordinates, and then use the distance formula to find all the lengths of each of the sides. Try these on your own. All right, so Spence, AB. What's the length of AB? Spence, what made that one a lot easier? What type of line would that be? That's a vertical line. I can count on a vertical line. BC, what's BC, Spence? 5. Pythagorean Theorem there, right? And what's AC, Spence?
4.
What makes AC easy? It's a horizontal line. XY, Spence?
3.
YZ?
5.
And XZ?
4.
The two triangles are congruent because why? No, what shortcut?
What number is this?
8. Side, side, side. And then how do you know that angle X is congruent to angle A? What 5-letter acronym do we like to say at the end always? CPCTC. Nice job. That's it. Here's your assignment for today.